So, continuing on algebra, all right? Good news for you, we're learning another thing that we don't have to work anything out. So, talking about properties, you did cover this a little bit in 5th grade, and we have talked about them kind of as we've gone through just a little bit, but we're going to be very specific with them today. Thinking about a property, okay? The easier way to think about this is properties are rules that apply to all numbers. So these are rules that we can say no matter what, this will always be true. The properties that we're going to deal with today all deal with addition and multiplication, so we're not having to worry about subtraction or division. If you drive from home to school and back, or if you drive from home to work and back, you're called a commuter, okay? Students that are in college that live at home and drive back and forth to college, they're called commuter students. If you drive back and forth to work, that's your commute. That's your travel. So I always think about that when we're thinking about the commutative property, because the commutative property says that the numbers can move back and forth, okay? This is the one that tells us if I have 7 plus 9, that's the same thing as saying 9 plus 7. So this would be the commutative property of addition. Then you have the same thing, 4 times 6 is the same as 6 times 4. That's the commutative property of multiplication. Very good. And you can also see this using algebra, using variables. If we have a plus b, that's the same thing as b plus a. And then if you have a times b, that's the same thing as b times a. Okay? Any questions about commutative? You guys are pretty familiar with that one, because we've thrown that out quite a bit. Okay? All right. Have you ever heard the phrase, choose wisely who you associate with? Yes. Okay. Your parents ever told you you're guilty by association?
Yes.
All right.
I hate that.
I know. Just because you're hanging around with someone and maybe they don't make a good choice, you're kind of guilty because you were with them. Okay? So there is a term called guilt by association. When you think about association, those are the people you hang out with. Okay? That's the group you're in. So when we think about the associative property, that is dealing with grouping, okay? And our grouping symbols will be parentheses. It won't be 100% of the time, but most of the time when you see parentheses, when we're talking about properties, it's going to be the associative, because you're talking about the groupings of numbers. What would I get if I did 9 plus 4? 13. Plus 3 would be 16. Ooh, we got to work on addition today. All right, 3 plus 9 now would be what? 12. Plus 4, 16. So it doesn't matter with addition what group I put them in. If I add them all together, I'm still going to get the same answer. So this would be your associative property of addition. And then the same thing with multiplication. It doesn't matter what group they're in. You're still going to end up multiplying them all by each other. So this would be the associative property of multiplication.
Isn't that also the commutative?
No. Commutative means you can change where they are.
Two of them?
Well, and it doesn't have to necessarily be just 2 of them. I could have 7 plus 9 plus 5, and I could change it up and say 5 plus 9 plus 7.
So you're not changing what you're adding with?
No, I'm not changing. No, this is where I have my groupings. So you will see parentheses when you have the associative, because you're talking about what you're doing first as opposed to after that. Yeah. All right. Then the last one we're going to talk about today is the identity property. Identity property for addition simply means anything added to 0 keeps its identity. For multiplication, it's anything times 1 keeps its identity. So again, with algebra, no matter what it is, my variable plus 0 will always be my variable, and my variable times 1 will always be my variable. Okay? Any questions so far? These are pretty easy, right?
Not really.
Yeah, you will be. You'll be surprised. Look at number 1. Okay? Do I have the same numbers? Yes. Are they in the same order?
No.
Well, they are in the same order.
Yeah.
But are they in different groups?
Yeah.
So what property?
Commutative.
This would actually be Remember, commutative deals with what order they come in. So this is the associative property, and we're going to say of addition. I'm just going to put the addition sign. So the associative property of addition.
Oh.
Now, I'm not going to be picky and make you write property of addition, because you should know, looking at this, it's all addition.
Associative property of addition.
That's fine. You're just being very technical.
Yes, you are. Yeah.
Okay, look at number 2. We have 0 plus 124 equals 124. Identity of what operation?
0.
Identity property of addition. Okay? That means anything plus 0 equals itself. Now, this is why I said doesn't always have to be 2. Look at number 3. We've got 20 plus y plus 6 is the same thing as 20 plus 6 plus y. That is commutative because we're changing the order. See, there's no groups, but I'm changing the order because I can move those around. And that's the commutative property of multiplication. Okay, what about n times 1 equals n? Identity. That is the identity property. Hold on. And that's the identity of multiplication. Okay? Now, when we talk about levels of understanding, levels of learning, this is the bottom of the building. This is the base floor. This is floor number 1. This is the easiest way, is just looking at them and identifying the property. Okay? Well, we want to up it a little bit. We want to go back to the 5th or 6th floor of the building. Okay? Yeah. So we're going to talk about if we have examples or expressions, I want to know if they are equal to each other, and if they are, what property tells me they are, and if they're not, why are they not? Now, before you yell something out, I want you to look at number 1 really closely. We've got 64 plus 0 and 64. First question is, are they equivalent?
Yeah.
Yes, they are. What property tells me that they will be equivalent?
Identity.
Very good. Because anything plus 0 keeps its identity. And that's the identity of addition. Alright, look at number 2. Are those equivalent?
No,
No. Why not?
because you can't
Divide 8 by, I mean,
Well, I could divide 2 by 8. I'd get 1/4 or 0.25.
because you can't
Because what now?
flip it with division.
Okay. If those were multiplication signs, it would work, and it would be commutative. But they're not. They're division signs. So we're going to say they're equivalent, and I'm going to say our reason is because it's division. And we don't have a commutative property of division. We can't change the order of division.
it's not possible.
Nope. Because we would get 2 different answers. 8 divided by 2 is 4, and 2 divided by 8 would be 0.25.
How do you know that?
Because 2 divided by 8 would be 2 over 8, which is 1 over 4, which is equivalent to 0.25.
Okay.
Just have a board that you can't put 8 into 2.
No. No, you can't. Period. Cannot change the order on division at all. Not at all. Now, if it were addition or multiplication, you could, but we can't change the order on division. Yes?
What if it's like 8 divided by 8 divided by 8? Could you switch the order again?
Well, you don't know which 8 is which 8.
Yeah.
But theoretically, no, you cannot. Okay, here we go. Number 3. Are those equivalent? Do I have the same numbers?
Yes.
And it's all,
Associate.
it is associative. So yes, they are equivalent. And it would be not commutative, because look, they're in the same, we just said that, hang with us. Okay? Listen to what we're saying. We're in the same order. My order has not changed. My groupings are the only thing that have changed. It's the associative property of addition.
Oh.
Let me remind you all that I am recording. Okay, look at number 4. 46 plus 15 and 15 plus 46. Are those equivalent?
Yes.
Yes. What property tells me?
Commutative.
Very good. Because I can change them. They can go back and forth. Just like we drive back and forth to school, I can change them. I can change the order on addition. Alright, looking at number 5. Are they equivalent? Ooh, we've got some divided answering there. How many of you think yes?
No.
How many of you think no? Pat yourself on the back.
Good job,
0 plus 32 is not 0. So these are not equivalent. Back to me, guys. If this were a multiplication sign, then our statement would be true, but it's not. If this were a 32, then we could say it would be identity, but it's not. So I'm going to say we have the wrong answer, because 0 plus 32 is not 0. We could, if it were multiplication. No. Well, we could say yes, they're equivalent. Yeah.
Oh, which property
Huh?
would it?
Well, you can't divide 0.
Well, technically, you can.
If you try to divide 0.
Right.
Right.
Doesn't have a value.
Exactly. Yes. Yes.
The only number difference are addition and multiplication.
Absolutely. All right, looking at number 6. Are they equivalent?
Yes. No.
No. Why not?
Because one was multiplication.
No. Okay, this is subtraction. Can we change the order?
No.
Okay.
It's subtraction, brother.
Now, if this were multiplication or addition, yes, we could change our groupings. But you can't change your groupings on subtraction. If I had 9 minus 7, what would I get? 2 minus 5 would be negative 3. If I did 7 minus 5, 2. 9 minus 2 gives me 7. So you're not going to get the same answer. And that is because you cannot change the grouping on subtraction. There is no associative property of subtraction. Okay? Alright, so any other questions so far about our properties?